Hello, good morning, everybody. As mentioned, I come from the University of Roma Tre. I am an architect, so I'm not, I'm not like a programmer. I'm not a person who directly acts on the Internet of Things. But I coordinate a team. I was project manager of a team that won the last edition of this competition. And I will speak about our experience, and I will also present the installation that we're doing here at the Maker Faire, so you can visit if you think it can be interesting for you. So the competition I will speak about is called the Solar Decathlon. The Solar Decathlon is a competition that between homes. So we've been asked, we started our work 4 years ago, we've been asked to design, engineer, build with our own hands and with a team of over 40 students coming from different departments of the university. And this is also part of the innovation that we try to put on the field, because it's not easy. It seems very strange, but it's not easy to bring students of engineering, students of chemistry, students of economics, and students of architecture together to work on a project. And in this case, it was a real prototype. It's important to know that this competition is not about how beautiful a house can be compared to another one, but it's called Decathlon because we have 10. This is Madrid, and the previous one was also in Europe. But we won the edition in Versailles, in France, next to the castle. So I was mentioning the Decathlon. These are the 10, fields where houses have to compete. We have 7 of these 10 fields where you have a jury, but you have 3, and sometimes in the American edition, 4 of these fields where the performance of a house is measured. So we have our homes were full of sensors that were kind of monitoring how the house was performing. And so this makes a problem of design very complex, much more complex than what we're used to. But it's not only a question of design, it's also a question of using the house. I heard a lot about speaking about the final user, and this will be the focus also of what I was saying. In our case, the users of the house were the same people who designed the house, who engineered the house, and who built the house. These are 2 of our students, and you can say it's like really having your hands on the prototype, but also on managing the house. During 2 weeks, where the performance of the homes are measured, you have to manage the daily tasks of a house. And this makes a big change, because in a house, you are not used to know the consequence of your actions. You don't know what happens to the energy performance, for example, when you open your windows, when you cook in a certain way. You know, you don't feel your home as like something that has a performance that impacts, in the end, energy consumption, because personally, before doing this project, I didn't even know how big is the, percentage of a global world energy consumption due to building and to housing in particular. And housing, you have to think about it, it's, you have a lot of different people who are homeowners. It's not easy to find a way to save energy with such a, variable amount of people. I mean, a home is not an office where that can be one energy strategy that's imposed to everybody. So we designed a house that included a lot of intelligent devices that had to be managed physically. So you have to be aware of what you were doing. So this is like, for example, a photovoltaic shield that was, it's a flexible, lightweight photovoltaics that was, we had reeds that could monitor the position, for example, of this house. You had, in these loggias, you had also thermodynamic balusters producing hot water. And we also won, as you can see. We had a good position in all the fields. And this is important because only integration can bring to such a success. And this is the way we try to manage. And this is what the point I want to make in this, to the debate. Because, you know, almost all of the other teams were saying, we control the house with automation. There was almost no need for people to be inside the house. So this means also for them it was very difficult to deal with unpredictable things, you know? You don't know a cloudy sky. You don't have a cloudy sky or clear sky. Sometimes you have like a variable situation. You have to decide when you do your washing machine. You have to decide when you open your windows. These are all daily tasks that you do every day in your home. There's an energy consumption related, but you don't know, you know, what are the consequences. So we looked at the other industries. We looked at the automotive industries. And in particular, to something that changed the way I drive. You know, by looking at this small number of what is the impact of what I'm doing when I drive, I changed my drive style. And it's important to, this is a very important point, because if I am on a hurry, if I want to see my baby, I can go fast, you know, but I know what's happening. Just, I only know it. There's nothing that's blocking my... and so we designed a system that's trying to do the same for homes. And we use in the solar decathlon. And I have to say, this strategy based on awareness of people, you have to know that the people who were, let's say, driving the house, in our case, were the same students who built the house, but they didn't know anything about the field before. So I think it's a good also point, because of course you have to provide technology to people who are not technologists, who are not experts of consequences of energy behavior. And so this is just to present us what is our concept and installation during the making. And we're looking at the concept of the Internet of Homes. So we believe that this is the Internet of Things Summit, but we believe that a very important driver of innovation in this field is on one hand awareness, but on the other hand it can be to put things and compare homes. Homes can be compared, but if you compare homes where a system that drives the home is based on user behavior, you're comparing users. And so all our work is now focused on giving the right set of tools and the right interface to users that can be also scalable to the existing building stock, because it's easy if you build a new prototype to shape it in a way that can work the way you like. But we have a problem of the existing building stock. So what do we provide to people? Is it just enough to give them an intelligent thermostat? Maybe, but we think that these two ingredients, meaning awareness and meaning putting things in a network, can really be a good contribution. I don't want to talk too much about the system, because also we'll be on exhibit, but I will be very interested to discuss with the audience also this point. So we use the bare conductive paint because we think there should also be a way to have lightweight interventions in the existing stock. Meaning, okay, I want to change the way I drive my home. What can I do? We believe you need a small production device. You know, we have solar panels on roofs, but what happens if I don't have a roof, right? Can we have small production devices? Because if you have the balance between production and consumption, your feeling about your behavior changes a lot. It doesn't matter if production is not, 10 kilowatts. So at least this is our experience. So this is our team that worked. I like to mention the team because too often things are presented like made by one person, one genius. But I think in this field, we need integration. We need to put people and different people together. And with technology, this is even more important. Because today, I suffer personally. We have an innovation lab at Roma Tre University, but still we're fighting the damn distinction between, the culture and technology. It seems so strange in the world we're living in, but I tell you, this is my daily experience, and I think this is one of the biggest challenges that we have to face. So, thank you, and I wait to talk with you later.